Welcome to this explainer. You know, we usually think of chemistry as this super sterile thing. Bubbling beakers, white coats, complex lab equipment, right? But honestly, the reality is that your everyday home, your kitchen, your bathroom, that cabinet under the sink is actually a secret battleground for chemical opposites. Today, we're going to explore the hidden chemical properties of the everyday items sitting right around you and uncover the actual science behind what makes them tick.
Here's what we're covering today. We'll look at the acids in your kitchen, the alkalis under your sink, extreme chemical opposites, how to decode those scary hazard labels, and finally, playing it safe with chemicals. Let's jump right into it.
Part 1. Acids in your kitchen. Take a look around your kitchen. Lemons, limes, that bottle of vinegar, maybe a fizzy cola in the fridge. It's kind of wild, but all of these have one big thing in common. They are all packed with acids. Now, don't worry, we're not talking about the sci-fi movie kind of acid that melts through the floor. These are weak acids. For instance, lemons and limes, they contain a weak acid called citric acid.
And you know what? Even without a chemistry degree, you actually have a built-in acid detector right in your mouth, your tongue. We can easily spot these weak, everyday acids because they all share a distinctly sour, sharp, and tangy flavor profile. Think about that physical reaction, that literal face you make when you bite into a raw lemon, or that sharp kick you get in a vinaigrette dressing. That sour tang? That is you tasting a weak acid at work.
All right, part 2, alkalis under your sink.
So if we move away from the fruit bowl and look under the sink at your household cleaners, things like thick bleach, washing soda, the heavy-duty stuff, we're dealing with a totally different beast. Unlike your food, these products pack substances called alkalis. Alkalis are absolute powerhouses for cleaning. That's exactly why they are the main active ingredient when you need a product to cut through really tough grease and grime.
But here is the catch. While we know acids by that sharp taste, alkalis have a very specific and, honestly, kind of concerning physical trait. If a strong alkali gets on your skin, it doesn't just sit there. It actually begins dissolving your skin. Because of that, it feels distinctly soapy or slippery to the touch. That right there is a massive red flag, and it's exactly why you really need to throw on those rubber gloves when you're doing heavy-duty cleaning.
So before we scale things up to the extreme stuff, let's lock in these everyday basics. On one hand, we've got acids giving our food that sharp, sour, tangy punch. On the other hand, we have alkalis, those powerful, slippery, soapy-feeling compounds lurking in our cleaning supplies. Keeping these completely different properties in mind is super important for what comes next.
Moving on to part 3, chemical opposites and extremes.
Here is where it gets really cool. Acids and alkalis aren't just different, they are literal, exact chemical opposites. Acidity and alkalinity are fundamental chemical properties, and because they're exact opposites, if you mix an acid and an alkali together, they actually cancel each other out. It's this brilliant natural balancing act happening right down at the molecular level.
Now, weak acids in lemons and mild alkalis in washing soda are totally manageable, but step into a laboratory and you will find their extreme cousins. We're talking highly concentrated lab acids like hydrochloric, sulfuric, and nitric acid. Over on the alkali side, you've got heavy hitters like sodium hydroxide, which by the way is a compound made entirely of sodium, hydrogen, and oxygen, along with potassium and calcium hydroxide. These are the pure, undiluted, intense versions of the stuff in your home.
And because they are so insanely strong, both extreme lab acids and extreme lab alkalis share one very dangerous trait. They're incredibly corrosive. Now, what does corrosive actually mean in the real world? It means they have the power to destroy living tissue. If one of these gets on your skin, it actively dissolves it and causes a severe chemical burn. So yeah, they demand absolute, total respect and caution.
Part 4, decoding hazard warning labels.
Since these lab chemicals are quite literally dangerous to handle, we need a foolproof way to know what we're dealing with before we even unscrew the cap. Enter the universal language of hazard symbols. Whether you're in a high-tech science lab or just grabbing drain cleaner at the local grocery store, these clearly labeled, diamond-shaped red and black symbols are there to scream danger at us. Spotting and understanding these symbols is chemistry step 1. Let's quickly decode exactly what the most common ones mean.
First up, the fire hazards. See that exploding bomb symbol? That simply means explosive. Pretty straightforward. It means the chemical can actually explode if it comes into contact with heat or a flame. The one next to it with just the flame means flammable. A flammable substance catches fire super easily, even without blowing up. Bottom line for both, keep them far, far away from any heat sources.
Next, let's look at direct threats to your body. That intense skull and crossbones, that's the universal toxic sign. It means the substance is poisonous. It's highly dangerous if you swallow it, breathe it in, or even absorb it. Contrast that with the corrosive symbol we touched on earlier, the one showing liquids eating away at a surface in a hand. That's your stark warning that the substance will actively destroy living tissue and cause nasty burns.
Finally, check out these two. A flame over a circle means oxidizing. This is a bit unique. It means the substance gives off a massive amount of heat when it touches other substances, which is an incredibly easy way to accidentally start a fire. Contrast that with the exclamation mark. That one stands for a general health hazard. It basically means the substance can cause significant harm, like severely irritating your skin or your eyes.
Okay, part 5, playing it safe with chemicals.
Knowing the dangers and decoding the labels is really only half the battle, right? We also need a strict safety checklist. Rule number 1, you must always stand up to work. Why? Well, if you drop something and it spills, it falls straight down to the floor instead of right into your lap. Rule 2, always wear safety glasses so absolutely nothing gets near your eyes. And rule 3, if you do spill an acid, wash the area immediately with tons of water. The water physically dilutes the acid and brings the danger level down.
Even handling the bottles themselves requires a very specific routine to avoid cross-contamination. Whenever you open a chemical, it's a strict 2-step process. First, take the top off and place it completely upside down on the desk. Second, the absolute split second you finish pouring what you need, you put that top right back on the bottle.
Now you might be wondering, why the upside-down top rule? Well, in chemistry, every single protocol has a very practical reason behind it. By placing the cap upside down, the acid or alkali that's clinging to the inside of the cap never touches your desk. It totally prevents leaving a hidden chemical burn trap for the next person. Plus, it stops desk dirt from sticking to the cap and ruining your pure chemicals inside the bottle. And putting the cap right back on, that prevents accidental spills and stops you from accidentally putting the wrong lid on the wrong bottle, which, believe me, could cause a total disaster.
I really want to leave you with a vital reminder about dilution. We just talked about adding water to a spill, and yeah, labs often use diluted acids because they're safer than highly concentrated ones. But make no mistake, dilute acids are still completely harmful. They can still seriously irritate your skin and your eyes, and those bottles will still carry the exact same hazard warnings we just decoded. You literally can never let your guard down, even if the chemical is weakened.
And that brings us to the end of this explainer. We've traveled all the way from the sour lemons in your kitchen to the highly corrosive alkalis in the lab, and we've learned the secret language of hazard symbols along the way. But the science doesn't stop here. I want to leave you with a challenge. Knowing what these symbols mean now, what hidden hazards are sitting right this second in your own bathroom cabinets or under your kitchen sink? I highly encourage you to go take a safe, careful look at the labels on your everyday household products. You'll probably be surprised by the intense chemistry living right under your own roof. Thanks so much for joining me. Stay curious and, hey, stay safe.